All right, guys. Today we are going to start our next session with trig. So I know you guys heard the phrase before. We are still in our chapter with right triangles. So this is just yet another way to troubleshoot and solve for missing pieces. First and foremost, when we use trig, I'm just going to kind of give you oh, that's so cool. You can type hola in there. I don't even know how you would do the upside down exclamation mark. Oh, that's so cool. Sorry, squirrel. But anywho, the idea for trig is that we are eventually going to be able to not only in right triangles solve for missing sides, just like we've been with the Pythagorean theorem, just like we've been with special rights, but this time with trig, you're actually going to be able to figure out the length of a side by a certain angle measure that's given. So it doesn't even have to be a 30 or a 60 or a 45. It could be 23.275. So all of what we're going to be doing will require a calculator. If you don't have one of the calculators like I do, your computer, your cell phone, it all has the calculators, the scientific calculators, but specifically what you are going to need this time around when we get into this is this button here that everybody looks at and wants to say sin. And that is not, it's an abbreviation, so it's sine, S-I-N-E, we'll talk about, but it's sine. This is not cos or cos, it's cosine, and that is not a color, it is tangent. And so these three buttons, as well as above it, you can see there's that sine with the -1 power, cosine with a -1 power, and tangent with a -1 power. All three of those, just like our calculators have done in the past, are the inverse of what's on the actual button. So like down here, when we first were introduced to squaring something, its inverse operation, the square root, was right by it. Our calculators are built that way everywhere. Remember, multiplication and division are inverse operations. Addition and subtraction are inverse operations. Even later, when we raise something to the third power, to the fourth power, to the fifth power, we've always used that caret. To undo a third power, we would take that right there. That's an inverse. In Algebra 2, you're going to look at something that's called logs. And its inverse function is 10 to some power. Or natural logs, and its inverse is going to be this number, just like pi, this number e raised to something. So our calculator is designed to have inverse functions by them. So these three keys are the ones that we're going to want to use a whole bunch later on in this chapter. So as we're learning the basics, I want you to keep in mind that a lot of where this is going to go is now truly what would be applied in real life. I so wish we were together specifically for this chapter, because once we're done with winter, which seems we don't ever want to be finished with winter, but once summer comes, like probably 3 days from now, knowing it's Ohio, typically we would go outside and actually measure trees. And that sounds so ridiculous, but it is something that we are capable of doing. So we're still kind of tossing that idea around, get you guys outside sometime next week and maybe try some of this. I'm going to see if that's possible. Try to do it myself, videotape it to show you, and that way you guys can kind of get an idea of how this really gets used in real life, not just on paper with pencil and practice problems. So that's where we're going. Right now you can see that we have a right triangle on our paper. And the first thing that we're going to concentrate on is, when introducing this, talking about our angles. So if I was in this right triangle, the first question I'm going to ask is, what side is opposite angle A? Oops. All right, so as you get that answer, type that in, please. The next question I'm going to ask is, what side is the hypotenuse? And as you get that answer, type that in. And what side intersects with the hypotenuse to form angle A? All right, so number 1 is BC. I agree with that. Number 2 is AC. Thank you for numbering them. Awesome. And so what's number 3? So far we are batting 1,000 here. Everybody seems to be right with everything that we're plugging in. So what side intersects with the hypotenuse to form angle A? Perfect. I see the first one come up, BA. You are all absolutely correct. One of the things that I do want, I'm trying to find a color. Color. We'll just use this one. The side opposite angle A is segment BC. You are absolutely correct. The side that's the hypotenuse, I hope we would all get that correct, and that is AC. And then the side that intersects with the hypotenuse to form angle A, that is, in fact, AB. So that's awesome. Nobody got any of those wrong. Now we are going to fix one thing, because in this, I've used almost all of the correct terminology, believe it or not. It seems pretty easy. You'd be shocked how many people get this wrong, though. I want us to concentrate on the fact that I asked you specifically opposite. And then I specifically asked you hypotenuse. Now, what I didn't do is I didn't use the specific word for that third question, because I felt like it needed to be described, because the side that intersects with the hypotenuse to form the angle. Again, the side that intersects with the hypotenuse to form the angle, we call that the adjacent side. Now, it's tough because, of course, when you look at angle A, you're like, what side is adjacent to angle A? Well, AB is what we determined, but some would go, well, it's AC, because isn't that right next to angle A? It absolutely is, but we've already named it as the hypotenuse. So that has it trumps. It's the better name for that side, so we'll never call the hypotenuse adjacent. The adjacent side is specifically designated for that side that intersects with the hypotenuse to form that angle. So these three, opposite, hypotenuse, and adjacent, are going to be big. So not to belabor the issue, but if I did it again and simply stated if I said, let's name the opposite, adjacent, and hypotenuse for angle X. So first question would be, what side is the opposite side? What side is the adjacent side? And what side is the hypotenuse if we want to now be from the perspective of angle X? So I suppose this would be 1, 2, 3 if we want to. What are we thinking? What's opposite of angle X? You are correct. Number 1 is PG. Perfect. Adjacent is XP. And our hypotenuse is XG. Now, again, you're probably thinking, how is this difficult? It shouldn't be. So what I want to do is now also show you that when we look at this, because I've specified angle X, a lot of times what you'll see me do is I circle the angle that we're talking about, and then just like our special rights, I'm going to label my sides according to angle X and its perspective. So from angle X, across from it, we know is our opposite, OPP. What makes the angle is our adjacent side, and our hypotenuse is probably the one that gets labeled first for most people because we have talked about it so much throughout this year. So if for some reason you ever, and I have seen it, it happens every year, we get confused with what's opposite and what's adjacent, I suggest label your hypotenuse first. If need be, circle the answer, and you can see that the side that touches the hypotenuse will always be the adjacent side. And that makes it a little bit easier to then figure out what I didn't touch with my circle has to be opposite. The other thing to keep in mind too is these little patterns that kind of show up. The hypotenuse and the adjacent side should share a point, X. They share that letter. The opposite side doesn't have the letter of the angle in its name. So that also helps know if you did it correctly. If I'm looking at angle X, the opposite side better not have X as part of its name. If I'm looking at angle X, the adjacent and the hypotenuse should both have X in it because that's where that vertex is located. So keep that in mind. All right, so that's the first part, and just some tricks to kind of keep in mind as we're going through this. So now let's talk about where the trig part comes in. All right. So when we're doing this, the idea behind our trig functions, and it is trigonometric, ratios that we're going to work with first. And let's break this down by what the words mean. And the first part, let's get a darker marker because we are on white paper and you are not going to be able to see that. I lost the blue. Oh well. Okay, so this part talks about these three words specifically right now: sine, cosine, and tangent. And next to them will always be an angle measure. So for right now, I'm actually going to do what your textbook does, and we're going to throw in this Greek letter. It could have been A, it could have been X, it could have been Z, doesn't matter. It could have been alpha, beta, gamma. This guy right here is the Greek letter theta. It just stands for an angle measure. That's all. Just stands for an angle measure. And by definition, it's going to, and if you look back on some of the formula sheets that I've given you, it will have a definition of our opposite side length over, notice that's where the ratio comes in, the hypotenuse length. So that's where all these ratios come into play. Cosine is our adjacent side length over the hypotenuse's length. Oops, too many E's. And our tangent is our opposite side length over the adjacent side length. Now, the purpose of all of this is, again, to create these equations. So you can see there's equal signs. These are actual equations that we're going to work out. So what you've seen possibly in the past is this information at the bottom of your sine our angle equals opposite over hypotenuse. You would see cosine of our angle equals adjacent over hypotenuse. And tangent of our angle equals opposite over adjacent. So you would see all of these as abbreviations. The opposite side length over the hypotenuse length, adjacent length, hypotenuse length, opposite length, adjacent length. And for decades, beyond decades, there is a mnemonic device, a way to remember something. And some of you have heard it before. So, toa. And to this day, as many years as I've taught this, and there's been days that I have taught this 6 times over in one day, this mnemonic device still rings through my head, and the first time I heard it was, weirdly enough, in 8th grade. And back then, eighth grade was eighth grade math. We were still doing sprint worksheets on multiplication and division, addition and subtraction. We weren't taking geometry in the eighth grade. So in this, the first word here, this is sine, and then the O stands for opposite, and the H stands for hypotenuse. And then we have cosine with adjacent and hypotenuse, and tangent which is opposite over adjacent. So that is by far the easiest way to memorize it. A gentleman who taught right before I came in and started my teaching career 21 years ago, Mr. Skimmon, used to tell his students, orange horses always have orange ankles. And he just chopped off the sine, cosine, tangent. Doesn't matter. As long as you have it memorized, you will always know what the ratio is supposed to be. Now again, the ratio is the big thing. It will help us with our equations. Your calculator will help do this work. Now what you're not looking at is the fact that this is actually a hidden proportion. Each one of these are hidden proportions. If I took this and put it over 1, you could see two ratios. If I took this and put it over 1, two ratios equal to each other. Put this over 1, two ratios equal to each other. So one of the things that we also want to keep in mind is that each of these are hidden proportions. Which does mean we will eventually look to cross multiply to solve. So don't be surprised when you're looking at how this is all set up, that when it all boils down, we're just going to have a proportion to cross multiply and solve. All right, so we have talked about how do we identify opposite, adjacent, and hypotenuse. We've now talked about what the Greek letter theta looks like, and that pretty much it just stands for an angle measure, whether it's angle A, angle B, angle theta, doesn't matter, but next to each one of these abbreviations will be written an angle measure. Most importantly right now, we are looking at memorizing opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. So COTOA is the best way I have found that will take care of that. All right. So, first thing we are going to talk about, and I'll write each of these now as example questions. Write all the trig ratios for the acute angles. And what you're going to now see is a right triangle and we're going to name this LMN, and this will be 6, 8, and 10. Obviously it's a right triangle. It's a 3, 4, 5 right triangle. 6, 8, 10 follows our pattern. So now it's a matter of we have to write all the trig ratios for the acute angles. Well, let's hope that we know that angle N has to be acute and angle L has to be acute because in a right triangle, only one is a 90-degree angle, the other two have to be acute. Doesn't matter what their measure is. So the first thing I'm going to do is I'm going to write the trig functions for angle L. And for angle L, there it is. For angle L, we're going to be up here. And I'm going to label my opposite side, my hypotenuse, and the adjacent side. And when I write my answer, I'm going to start with our first trig function, sine, not sin, sine. No, I don't know, it is one of my biggest school pet peeves. We won't even get into some of the other pet peeves I have, like mouth noises and loud chewing and bleh. But next to sine, we are going to put our capital L, because now that's the angle measure, not theta floating in there. We're going to put our equal sign, and we know that it's supposed to be opposite over hypotenuse. So opposite is 6, hypotenuse is 10. Now, never leave a ratio, because a trig, this is the whole point, it's a trig ratio. You do not leave a trig ratio not simplified. So our final answer would be 3/5. And that's it for now, because we're only writing the ratios. So write all the trig ratios. That's it. That's where we stop. So then when we do cosine, because it says all the trig ratios, cosine L is adjacent over hypotenuse, which would reduce to 4/5. And then tangent L is opposite over adjacent, which would be 3/4. Now, that's one of the acute angles. Problem is we want both acute angles. So now we're down here at angle N, and I have to now label, because my opposite and my adjacent will change because I've changed the perspective from where I'm looking. So right now, the good thing is our hypotenuse will not change, but our adjacent does change, and our opposite does change. So that's why you'll see a lot of what I do is obviously color-coded, so that now we're following the colors. So if I want to do sine N, I'm going to have opposite 8 over the hypotenuse 10. So now sine N is 4/5. Cosine N is adjacent over hypotenuse, and now that's 3/5. And tangent N is opposite over adjacent, which is 4/3. Now, there is clearly a pattern. We are using the same numbers. It's not like we're creating a new triangle just because we went to a different angle. The reason you're going to find that there's this pattern of what sine was for one angle is cosine for the other, because we want these numbers to still show up where they've been placed. This is the opposite over the hypotenuse. So your hypotenuse shouldn't change. They should both be the same number at the bottom. If I'm at angle L, the opposite side was 3, but now that I'm at angle N, that means adjacent should still be 3. It shouldn't change. because I still need that to be there. So what we're looking at is our trig functions adjust according to the location of the sides. And no matter what, if this triangle exists, there's an angle measure here, and there's an angle measure here, and it won't magically change just because I've decided to use a different equation. The configuration of that triangle will not change. So these have to adjust to make sure that these always stay consistent. And notice our tangent. They are reciprocals of each other. And that's because, again, the only thing that changes is our perspective from where we're at, not the actual lengths of the sides. All right, so with this one, it says write all the trig ratios. That's what we've done. Now, had this triangle started with 3, 4, 5, there's no simplifying. But because it started at 6, 8, 10, you need to reduce if they're talking about the ratios. All right, so the next question, using this information, if cosine of angle G is 7/25, find all the other trig ratios for right triangle EFG. So we're going to write this triangle, and that's what the question would be. And what we have to do now is we have to think about what is our definition for cosine, what is right triangle EFG supposed to look like, and we now have to create all of that. So the first thing I'm going to do is I'm going to draw EFG, and I'm only supposed to make sure, because it hasn't been specified, angle F has to be the right angle. They didn't describe it for me. I know sometimes they give horrible explanations and they'll rename this some crazy name and then tell you what the right angle is or tell you what the hypotenuse is. If they don't, you are supposed to remember that angle F, that middle letter, is the right angle. And then it doesn't matter. It doesn't matter where you put E or G. It doesn't matter. As long as E and G are the acute angles, it doesn't matter where you put them. So that's the first thing. That takes care of our right triangle being drawn. The second thing that I need to take care of is this guy. And I have to remember that cosine of our angle is supposed to be adjacent over hypotenuse. So I need to make sure whatever I do, that adjacent over hypotenuse gets labeled correctly. So our definition of cosine is adjacent over hypotenuse. So I'm going to come to angle G. I'm going to now label the hypotenuse and my adjacent side, which does mean over here is my opposite side. And according to this, 7 has to be the adjacent side, and I'm going to make this. So here's our adjacent, and here's our hypotenuse, because that is the definition of our trig ratio. So adjacent would be 7. Hypotenuse would be 25. Now it's a right triangle, so does anybody want to take a guess as to what EF should be? What should I put here for EF? Yep, bravo. It is a Pythagorean triple, so we want to put 24 right here. And you don't have to do the Pythagorean theorem. Now, obviously, most times, the Pythagorean theorem will help you find that last side. This one was our Pythagorean triple. So it pays off to have those memorized because you don't have to worry about wasting any time looking for the missing side. So now that we know that our definition is adjacent over hypotenuse, we've labeled adjacent, we've labeled hypotenuse, we used our Pythagorean theorem or knew it was a triple to get that last one. The only thing now we have to do is find all the other trig ratios. So we've already known that cosine of G, so if I do sine G, which is opposite over hypotenuse, we can fill that in. And we already have cosine, so tangent of G would be opposite over adjacent. And yes, it's improper, but it's a ratio, so we know we leave it that way. So then the only other thing I have to worry about is the other angle. So now that we're up here at angle E, our hypotenuse won't change, but our opposite and adjacent have to adjust because we don't want our angle measures to show up someplace different. We don't want our side lengths to show up somewhere different. So now when we do sine E, we end up with opposite 7 over 25. Cosine E is adjacent 24 over 25. And tangent E is opposite over adjacent. And I know I did this correctly because I can see that there's this switch. Sine and cosine ratios have to match because the side lengths shouldn't magically change. Our tangents are reciprocals, and our cosine and sine ratios match. So remembering that this is a right triangle, I can look here to then determine where I place everything and then use the Pythagorean theorem to find the last spot. Okay, so let's just review real quick before we do one more example and we're done for the day. We talked about how to identify opposite, adjacent, and hypotenuse. Had those. We talked about what the definitions were for our ratios. We did introduce theta as our Greek letter that might show up for our angle measure. We showed our abbreviations. We showed our mnemonic device. We said that each of these are actually hidden proportions. that each of these could be over 1, and I would eventually cross multiply to solve for a missing piece. Then we looked at these two examples just as practice as to how to set up the ratios. Again, we're not solving for any missing pieces here, we're just setting up the ratios. Did a problem where our ratios weren't already here, we had to use our knowledge to then set up our triangle to find all of our ratios. All right, so finally, what is this going to do? Well, we had our Pythagorean theorem where we did see we could find a missing piece. We then had our altitude on hypotenuse formulas that told us in a certain situation how to solve for a missing piece. We had our special right triangles that now narrowed this down to only one side is given, but we had to look at the angle measures to know what it would be, and we had like a shortcut. We had formulas for that. Now, I'm going to ask you if FG is 13 inches and angle G is 63 degrees. Uh-oh. That's not 30, 60, 90, and that's not 45, 45, 90. And all I ask is find EF and FG. And that's it. EF is going to equal something, and FG is going to equal something. Now I got to figure out how do I solve this. Well, we started this with trig functions. Remember, functions was a fancy way to describe some of our equations. So that's what we're going to do. We're going to set up our equation, and we're going to use our trig ratio to do that. So keep in mind that we need to look at where our angle measure is. So I'm not telling you what angle to use in the directions. We need to first find the given angle. That's right here. That's the first thing. The second thing is going to be label your sides. So very similar to our special right triangle, we look at our angles, 30, 60, 90, 45, 45, 90, and we make a decision. What formula are we going to use? What shortcut are we going to use? So the same thing here. We look at our angle, and now we're going to label our sides the same way, except this time we label hypotenuse, opposite, and adjacent. The third thing that I want to do is pick the first or only side to solve for. I'm going to assume we're all going to want to solve for EF because it's listed first, so let's solve for it first. So here we're going to pick EF. I look, and EF is labeled opposite. The given side is 13. So what I'm looking at is when I go to solve for this, EF is opposite. 13 is adjacent. Opposite and adjacent fit the tangent ratio. So that's why I'm going to pick tangent. It's not my favorite. It's not just the one I like to write. It's because those two words fit our tangent ratio definition. So if I wanted to solve for EF, I'm going to do tangent, and instead of G, it tells me 63. So I'm not going to write G anymore. I'm going to substitute in that number because I know it. And then I'm going to write my definition. Opposite, EF, over adjacent 13. So notice how this is very close to what we did here. Tangent G, and we had two other numbers. But down here, we didn't have a number for the angle, so we left it as just the unknown, the letter. Now we know what it is, so we're plugging in 63. We don't know what this opposite side is, so now that's our unknown. And there's 13 for our adjacent side. The next step, you are going to go into your calculator your calculator has stored every possible angle measure. There is an algorithm worked into your calculator that knows what every ratio should be for every angle measure, given the definition of either sine, cosine, or tangent. So without this calculator, you cannot solve. So first thing that I'm going to show you is way down here on your calculators. It's tough to see with the glare and the fuzz, but that guy right there at the very, very bottom should say DEG for degree. This button right here, DRG, that'll change it from degree to radian. And this guy right here, gradient measure, that's a physics thing, and I can honestly say I've never, in all of my years of high school, college, teaching, never have used that. You will next year in Algebra 2 use this one. This guy degree is what you want, and it has to be underlined, and then you just push enter, and that'll make sure that this guy at the bottom says DEG. Some of you might have to go to a mode button to change it, and I do believe even on the cell phones, it will have the same thing. So if it's not in degree, all your answers will be wrong. So the first thing I'm going to do is I'm going to go to my calculator, and I know that it's 63 degrees. So I'm going to push tangent, notice how it looks identical to my paper, 63, and I'm going to push enter. Now, here is this ridiculous looking decimal. That is the ratio that I am supposed to have over here for a 63 degree angle when we're talking about opposite divided by adjacent, because my calculator has that stored. So I talked about these were hidden proportions. You're going to now write down this decimal number, oops, let's use the same color. I don't know why I picked that up. 1.9626. We're going to put that guy over 1. Everything I do, we're going to put over 1. Equals, and we're going to bring down EF over 13. So I went to my calculator, I punched that in, and now I have this decimal over 1. This number is what this guy's supposed to turn out to be. So kind of like 3 over 4 comes out to be 0.75, or 1/2 is 0.5. That's what all these are. These are the decimal versions of what my fraction should be. So to figure out that missing piece, we cross multiply. So our last step is cross multiply. And what's really great is in most cases, you're going to cross multiply and you're finished. 1 times EF is just going to be EF. 13 times that decimal, as long as I haven't gone clear crazy, that number's still sitting there. Just push times 13, and I have that number, 25 point. And you'll be told where to round. I'm going to suggest round to the nearest tenth right now. A lot of my work, I have a habit of rounding to the nearest hundredth, and that's just because that's where I was always told to round. So here is my answer for EF, and I'll plug that in right here, 25.5 inches. Now I did all those steps, but if I want to find what the hypotenuse is, I'm just going to go through the steps again, pretty much the same way. I'm going to figure out what trig function fits EG. Well, if I want to solve for EG, EG is the hypotenuse. 13 was our adjacent side. Hypotenuse and adjacent fit cosine. So I've now determined that I want to use cosine. And so I'm going to write cosine of 63 equals adjacent over hypotenuse. And the only difference now is when I go to my calculator, I'm going to plug in cosine instead of tangent, 63, enter, and it will tell me it's that decimal. So 0.453, and I know there's 2 9s and a 0 and a 5. I'm not going to clear my calculator screen, so I'm just going to write that much to keep track of my work. I'm going to recopy down, and I'm going to cross multiply and solve. Now when I cross multiply, I can see that I'm going to have some number times EG. And now I have to worry about dividing. And so the reason I kept this on my screen is I want all of those decimals to be accounted for. So here's the great part. I'm going to do 13, notice I'm not clearing my screen, 13 divided by, and even though that disappeared, we're going to push second, answer, ANS, copy and paste that decimal that had the 45399 number. All of it is copied and pasted there, so I'm dividing by everything and I didn't have to memorize it. And now I'm going to push enter, and I find out that EG is 28.634, means I'm going to stop at 28.6. So up here is 28.6 inches. Now we're going to do a lot more of this on Wednesday, but I want you just to double check. Does that make sense? Is a length of 25.5 compared to 13 going to make sense? Well, opposite the larger angle should be the longer side. Opposite the largest angle should be the longest side, so that makes sense. So the only thing that you're going to be asked to do besides practice the notes is I'm going to give you 3 questions. The 3 questions for practice are going to look like these examples. Write the ratios, figure out the ratios, and solve for 2 missing sides. And then we're going to go again Wednesday over how to find side lengths without all of these steps written down each time. So make sure you go back through the notes, rewatch the video, look for my 3 questions, and Wednesday we're going to do a ton of examples on solving for sides, and then for the first time, solving for angle measures. Thank you for your participation today. Look for those example problems in Google Classroom here shortly, and I hope you all have a great day. Are there any questions? All right, guys, have a great day.